Can you believe we live in an age where this and this are connected to each other?
This summer we did an internship with the Dunlap Institute of Astronomy at the University of Toronto.
We got to do some really cool research through our internship, which gave us insight about space, telescope, wavelengths, even coding.
While learning about all four of these concepts, we investigated interacting galaxies and how they can collide with each other. The Milky Way is no exception.
Wait, hold up. Is our galaxy gonna be in a collision?
Well, eventually, the Andromeda and Milky Way galaxies will collide.
Wait, so are we gonna die?
Not necessarily. It should happen in about 4.5 billion years from now.
Okay, thank God. I'll graduate high school before then. I got this.
It all starts with coding. I use Python, one of many computer programming languages, to interpret data, simulate images, and draw contours around galaxies. I also use it to locate interacting galaxies to confirm whether they exist or not.
We also use the code to differentiate between different types of galaxies.
Using coding gives us what we know and lets us know what we don't. So by using the knowledge we do have and the amazing power of speculation, we can learn so much more about interacting galaxies and how they affect us. The really cool thing about this is, sometimes it's difficult to tell the difference between interacting galaxies and a pair of galaxies with just a telescope. Add a little bit of Python and cross-referencing in the mix, and it will let you know which one it is as easy as that. No cap, coding is just straight fire.
Now, let's take a look at telescopes.
Wow.
Not this one though. Telescopes are optical tools that allow us to look into the night sky, to ponder at stars, planets, and even other universes.
We use the Square Kilometer Array telescope, one that's probably 20 times bigger than your house. We use the ASCAP telescope based in an Australian desert, hundreds of miles away from the nearest city. It's comprised of individual telescopes placed many meters apart in a circle, so it can take up a huge amount of light in the sky.
The telescope survey we use is called EMU, a subsection of the ASCAP telescope. We study different sectors of the survey. An astronomical survey is a map or an image taken of a part of space in order to view the objects in that area. Think about it like a professional satellite map of your city, but for space.
Now, let's talk about wavelengths.
Think about everything you've ever seen. Every color of the rainbow falls into a range called the light spectrum. It is comprised of all light that is visible to the human eye.
Oh, did you know that there are rays of light that are above and below the visible light spectrum? Now, this is because there are waves of light that have more and less energy than visible light.
These light waves are organized into different divisions called wavelengths. As you go past red in the light spectrum, you get waves of less and less energy. First off, there's infrared light, then microwaves, followed by radio waves. On the other end, you get waves of increasing energy, starting with ultraviolet light, followed by X-rays and gamma rays.
Some telescopes are made to view invisible light in different wavelengths. Being able to see these lights in the night sky means that astronomers can also view stars and galaxies even though they're invisible to the naked eye. When galaxies collide, one of two things can happen. If the galaxies vary significantly in mass, the larger one will absorb the smaller one entirely while retaining its shape and staying intact. This is known as a minor merger.
Think of a whale eating a fish, or Pac-Man eating a ghost.
But if the galaxies are similar in mass, like Andromeda and the Milky Way, then it's called a major merger. New stars will form, gases will combine, and this will create an elliptical galaxy.
Now, there's a lot about space we still don't know.
It's important to keep on researching because the way we learn about our night sky helps us understand what we might face out there in the universe.
By studying interacting galaxies more closely, we know that we are not in danger of another collision, at least not for another 4.5 billion years.
Assuming the sun doesn't kill us first.